Okay, so we will get started. Very good evening, Kunal, and
Good evening.
thank you so much for joining us in this platform.
No, thanks.
Uh,
Thanks for having me over.
and the audience, folks, for joining us online right now. Really appreciate we picked up a time which is rather late in the evening, so that we can really have you focused and not, multitask with your office job. So. Thanks for the attention. I'm personally really excited. I don't know how many of you already follow Kunal, but in your journey of, your data science, I'm sure you would be. So let me start by a little, very tiny introduction, really, because after that, I want Kunal to help me understand his journey. So Kunal, what I know of you is, from your profile, really.
Mhm.
Uh, you did aerospace engineering.
Yeah,
And then you somewhere dived into data analytics and you founded Analytics Vidhya, right?
right.
So if you can help me bridge this journey, aerospace
Yeah,
engineering to data science.
yeah. It is. To be honest, I mean, when you look at it in the rear view mirror, it looks disjointed. But you know, to be honest, computer science and coding was always. Enticing and so I remember making a software for my dad back when I was in class 11th and I was studying C++. Uh, so computer coding and in general computer nerdiness was always there. I believe to some extent. But as part of my degree, I studied aerospace engineering. So my bachelor's and master's was in aerospace engineering. And then what happened was when I was kind of passing out from my college, the career options which I had in aerospace at that time were kind of limiting, especially in India, and then it which essentially meant that if I go out of India to pursue my career in aerospace, I would need to do further studies, which which at that point I wasn't prepared for. So I was looking for options, and then Capital One came to campus at that time. And when I inquired about the job profile, it looked interesting. So when I talked to people, they discussed some of the things which I'd done as part of my master's thesis. So some of the underlying algorithms. So within aerospace, my specialization was in computational fluid dynamics. So some of the algorithms which I was working on were being used at Capital One as well. So I thought that it looks interesting that you're not only using your mathematical skills, but you're also making business impact. So that's how I joined Capital One back in 2006. And that was when I got exposed to analytics and data science as we call it today. Uh, so I spent about 3.5 years working in Capital One across various roles, so risk management, customer management, to customer acquisition. And back in 2010, I then decided to come back to India because I wanted to be in India in long term. And at that time, I came across the opportunity with Aviva Life Insurance. So I joined Aviva. We started this team, analytics team, which then scaled from a 2-member team to a 20-member team by the time I left Aviva. But what happened during this period was, this need of having a data science ecosystem kept coming back again and again. So just to give you examples, for example, so if I was building a model for, let's say, customer retention, one of my friends called me one day and asked that, have you included any macroeconomical variables while doing persistency modeling? And I said, no, but that sounds like an interesting idea. So people were actually doing these discussions in their micro circles. So I would call up my batchmates when I needed any help, and that need kept coming back again and again in various shapes and various forms. So then in 2013, I said that, while I don't know how to solve the larger problem, let me start sharing my perspective and my learnings through a blog, and that's how Analytics Vidhya started. So April 2013, I booked the domain and I started the blog based on how I was seeing analytics evolving at that time. So, and this was, very early stage for analytics and data science as we know it today. So at that time, machine learning was not as a bigger focus area as it is today. But I could still see a lot of impact. So that's how Analytics Vidhya started. And I continued Analytics Vidhya along with my job for about a year before I quit Aviva and started doing this full time. So yeah, that's how the journey went through.
Right. So I think what I really caught very well in your answer was that the business requirements and the needs were driving people to discuss, and you
Yeah.
could see that potential. So
Yeah.
it wasn't McKinsey's report that data science is hot
No,
at
no.
that time.
In fact, yeah. So it wasn't to do anything with McKinsey's report, or and to be honest, till about year and a half into Analytics Vidhya, I wasn't even sure how big the market is, or how big the community is. In fact, I very clearly remember on my last day at Aviva, and at that time we used to get some 8,000 visits a month on Analytics Vidhya. So one of my colleagues said that, it's good to have a personal blog, but how big do you think this can become? And at that time, my answer was that, if this becomes 4x of what it is today, I'll be happy. So, so I had no clue how big it would be, or how much impact. What I could see was, people who were following us were really liking what we were doing, or the kind of content we were putting out there was really helpful to people. So that I think was the main reason, and I mean, it was more gut-based decision at that point, but thankfully I took that call.
Cool. I like that gut-based decision for a data scientist. That's a good statement to start with.
Yeah.
So tell me, Kunal, considering that it was initial sharing and content focus, today, how do you see Analytics Vidhya's? What are the main offerings, and how would you kind of say what is your top three, if you could help summarize that?
Sure. So what we are building is basically, a platform, a knowledge platform for analytics and data science professionals. And the idea is to, create a community where people come for sharing knowledge, and while they share knowledge, or while they engage on the platform, they create knowledge or they gain knowledge, right? So in terms of top priorities, clearly building community is the core of whatever we are doing, and the community today is getting built by multiple initiatives or multiple engagement points. So we have a blog which gets read very widely. Then we have discussion portals, we have meetups, we have webinars, we have workshops. Later this year, we are doing a conference. So really building a community of these people, and addressing their need across the board is what Analytics Vidhya stands for. Now within this, there are some initiatives which we see really working well. So hackathons, for example, get a lot of attention from the community. I think it's a brilliant way to kind of apply yourself and test yourself and learn in the process. So hackathons get a lot of attention. The conference, which is coming up later this year, is going to be a unique conference in itself in India. So that's how the portal is shaping up. But the way I would look at it in long term is basically we are building a professional identity for every data scientist. So tomorrow you can go out and say, this is how I look on analytics Vidhya. These are the competitions I have participated in. These are the articles I know or I have read. And these are the webinars or events which I have been part of. So that starts telling people who you are as a data scientist, and then it should also help us make things a lot more personalized for the community.
Okay. So I, I like the way you're using a much broader ecosystem as your objective, because clearly having something based out of our country and something more local, as aspiring folks and people in the industry, I think is it makes knowledge sharing and contextual knowledge base much
Yeah.
more easier. Otherwise, if everybody is only focusing on the Kaggle of the world, then I think it's like all the competition there, all the data sets there come from
Yes.
the major markets. Like they
Right.
come from
Right.
the
Yeah.
Western world, to say.
That's true. In fact, the way we look at competitions is actually very different compared to what a Kaggle looks at. So if you look at a typical Kaggle competition, there would be a month-long competition with a huge prize money and a really difficult research problem out there, which is great for the top data scientists, which is great for matured markets. But in India or in developing markets, things are very different. So most of the companies in India would be happy to have a quick model in a few days and then go out and implement that. So that's why our hackathons tend to be short duration hackathons, but a lot more intense and a lot more activity going on around the hackathons.
So on the topic of hackathon, actually, I do want us to spend substantial amount of our, today's hour on this topic. Simply because target large audience today, and people who are looking forward to listen to you want to understand how do they kind of jump in from their learning and early experience to deep dive into what's happening in the industry. And I think your hackathon, what I really enjoy is that your hackathon are connecting industries in a larger way, like recruitment, hiring, right?
Yeah.
So if you can talk about one of your hackathons, and particularly maybe, if you're okay with, use the example of fractal analytics, because, the job descriptions were listed out, the hackathon was on, right? And there was that mapping happen. So take us as, level of insight and depth you are comfortable with, right?
Sure.
From approach to fractals view and the participants view, right? Both the angles.
Right. So let me, start with how does hackathon as a product stand in industry, and then what are some of the really unique aspects about that product. So, if you look at the way companies used to interact with people traditionally. So, for example, if a company wants to hire people, and they would go through traditional, recruitment channels. So they'll have their own consultants finding out people, and that's a really expensive and a time-taking process. So, and then a lot of times people who are searching don't really understand data science. They don't really appreciate the difference between various terminologies. So it becomes really difficult to, hire people through the traditional channels, especially in a niche industry like analytics and data science. What hackathons do is basically, they turn this model completely around. So they say that, any hiring or any So hiring is just one use case, but hackathons have multiple use cases. So you can use them for crowdsourcing solutions. But what they do is, they open up a platform for a at a huge scale. So thousands of people can simultaneously solve a problem or compete for a recruitment position, and all of that happens within a few days. So for example, in case of Fractal, or in some of the previous hiring hackathons, we have seen thousands of people competing for various positions, and then getting recruited within a month compared to the normal hiring cycle. So that's where so you're doing skill-based hiring. You're doing a lot of hiring in a very condensed form, or if you're solving problems, you get the best solution out of the best data scientists across the globe. So as a product, hackathon turns a lot of things completely around, and it's a very unique proposition. And for people who are participating, they can have much more meaningful discussions. So the companies whom they are interacting with are convinced about their skill sets by the time they go and interact. So they can spend their time understanding what the role is, what the team does, what are some of the problems which they are facing, rather than going through the traditional technical rounds of interviews. So that's where we see a lot of attraction from our clients, from our community, and typically in form of how hackathons happen. So for example, in case of Fractal, we understood what the requirements were. We posted it out on the website that these are the positions for which the company is hiring, and interested people then kind of fill out their interest. And on the day of competition, they get a problem statement. And all of these problem statements are sourced from live industry problems. So all of these are real life use cases which have been faced by, so actual data scientists would be working on these problems in their day-to-day roles. And then that's where the beauty of the thing comes. So when people, look at the solutions, they can relate to what the person has done. So all the solutions which come, so once the competition starts, people can download the data set, people can read the problem statement, and then they start uploading their solutions, and they try out various tools, techniques. So in terms of tools and techniques, the stage is widely open, so people can use any tool, be it R, be it Python, be it SAS. People can use any technique. So people use a range of techniques, starting from simple linear logistic regression models to all the way up to boosting algorithms, so XGBoost, CADBoost, or now even neural networks and deep learning. So you see a whole range of solutions coming out, and then in some cases there are solutions which are very specific to industry problems. So right now there is a hackathon going on for click prediction problems, and there you see, for example, online learning algorithms doing much better than some of the other algorithms. So this kind of exposure, even if you are someone who is new to industry, is something which is really unique. So if you think about it, as a end user, I'm working on the same problem on which thousands of other data scientists are working. And in the beauty in the community setup is that people share their solutions very openly. So for example, if I build a solution and I'm right now at rank 100 on the leaderboard, I would post it on the Slack channel and say that, this is a script which will take you to rank 100. Go on and improve on this further. So you get this pooling. So I've seen people becoming better data scientists just by the fact that they've religiously come to these hackathons. So people come, and in a period of 2-3 days they learn so much which they wouldn't have learned in their jobs or through any, let's say, coursework. So in that sense, hackathons provide this really unique opportunities, irrespective of whether you win a competition or not. There is tremendous amount of learning which happens uh, in a hackathon. Uh, so over a period of 2 days, typically we see the community exchanging anywhere between 10 to 15,000 messages among themselves. We get on an average 8 to 10 solutions per participant. So people try out various models, people try out various tools and techniques. And by end of the hackathon, they then mark what they think is their best solution. So people mark that solution, and the platform then automatically scores the solutions based on their accuracy or objective criteria, which is defined upfront for them, and puts out a leaderboard in real time as soon as the competition finishes, that this is where you stand. And then thereafter, the recruitment process can start immediately. So that's how a typical hackathon works. In terms of if you're let's say if you want to participate in a hackathon, I think the best thing to do is to start with a few practice problems which are there on Analytics Vidhya. So they give you a flavor of these same problems, but in a non-competitive environment. So you'll find tutorials for these problems published on Analytics Vidhya. You'll find a benchmark script. So that's a good place to start. That's a good place to understand how you improve your models, or what are some of the tools and techniques which can be used to make your models better. And irrespective of whether you use R, Python, or SAS, or any tool, excuse me. It's a good exercise to practice on a few knowledge problems or practice problems before you get into a competitive or a prize money hackathon. Once you've done that, if you're new, you should again try and see what other people are doing. What are the discussion portals? Typically, people mention what were the tools and techniques they used, or people share that openly, and try and learn as much from your peers or the best, best participants out there. So another thing which we do is post a competition, we release the solution to the community. So the topper solutions are made available to the community, so that you can see, how the best data scientists have approached the same problem. And that's again a huge learning. So you not only see where you stand, you also see where some of the best people stand, and what kind of feature engineering did they do, what kind of transformations did they do, how did they go about missing value imputations, what kind of techniques or ensemble modeling did they use to make their solutions better. So that's the best way to kind of learn. And then a lot of times people also come across techniques which they were not aware of, but you can always go back and search about algorithms today. You can always go back and see what that algorithm means and where it can be applied. And that's where the entire hackathon model comes together brilliantly. The kind of results which I've seen, the kind of impact I've seen on people who participate regularly is just tremendous.
So there is a potential to create heroes out of these hackathons.
Yeah. In fact, it's great that you mentioned that. So because we had seen so much impact, we actually published a few stories on Analytics Vidhya, where people started as a by following us, or they were doing some courses parallelly, but through the experience they had across multiple hackathons and the way their career transformed through that, it's just phenomenal.
Right. So clearly, I think persistence is what you're bringing out. So as the hackathons are on, collaborative learning, reading other people's stuff, writing your own, it's okay, you're not being competitive right up front, but participative instead of, holding back and waiting for one day to start writing code.
Right?
and then post hackathons, reading up the solutions, picking up those best practices, reading, and then having certain kind of goal that when you are going to be more active in the coming up hackathon. So that's something which people can plan as their individual career based on the pace they want.
Correct. And at times initially it might feel intimidating to people when you come up in a hackathon for the first time. But if you come for 2 to 3 hackathons, you start getting the knack of things. You understand how people quickly come up with solutions. What are some of the simple ways to create effective solutions? So, for example, in a lot of problems, you can come out with a very simple solution by just simple averaging or averaging over segments, and that's a really smart solution to come out in 5 minutes or 10 minutes. And then you can always kind of improve on that going further. So I think typically it takes anywhere between 2 to 3 hackathons for people to kind of get the hang of it. But once they've crossed that stage, they start enjoying hackathons. They start enjoying and looking for these pieces of insights or nuggets. And then a lot of times there are really interesting outcomes which come out. So, for example, in one of the hackathons, where we were working on a truly big data set, one of the participants who came second, he had created more than 1,000 features in a period of 7 days, right? So there was more than 1,000 variables which the person had considered in their predictive model. The person who came first got a better solution by just using 14 variables. So that's the beauty.
So the beauty of reduction is clear between top 2 solutions.
Exactly, and it also tells that it's not just about applying more machine power. It's not about just putting grunt power at work. It's a lot about how you go about thinking about the process, how you develop new features, or how much business do you understand while you are participating or working on a particular problem.
Cool. So for everybody who's watching us, I think the key message for you is go in. When you come out of the first one, don't kick yourself, right? It's expected that it's going to be hard for you, right? It is going to be intimidating, but don't let it fall you down. Instead, that's how it is. And be persistent. Go with your second, go with your third, keep reading, and that's when you will start seeing yourself participating. I think that's a very, very important message because, this is what, since I interact with a lot of, folks who are learning, who are reskilling, somewhere for them to have this confidence that one needs to keep learning and starting to participate in hackathon. Do not wait to go and learn all your advanced machine learning or finish your deep learning, finish everything, and then you will think you will participate in hackathon. Right? That's clearly, Kunal, is not what we ask people to do.
Yeah, in fact, to be honest, you can come and participate in a hackathon if you know linear logistic regression and decision trees. If you know those 3 techniques, you're good to compete in any competition and have a few solutions out there and see how the process works.
Wow, that's a very succinct summary of what is the kind of skills you can bring on and be confident. I like that. Thanks, Kunal. So I'll shift a little bit of gear here because let's get a few more insights from you since you work with the industry. So now that with the years things are stabilizing in terms of businesses knowing what is the space of both big data and analytics, and they want to they're looking to solve those problems versus in the earlier years, it was still trying to figure out what to do with analytics. So now, how do you see the space? What are the different kind of companies? Where is the actual work happening? Where is the myth busted and where is the actual work happening?
Sure. And I presume that's specific to Indian industry right now, right?
Yeah, yeah. Let's consider the Indian industry.
Sure, sure. So, broadly as I see it, I can, look at industry in four different parts. So, there are four kind of companies which you can look at, or four segments, so I'm back to my clustering days. So the first set of companies are, companies who are apply. So these are your captive units or traditional analytics units where there is a product which is there, which may or may not be a analytics product, but you are applying analytics to improve your product offerings, right? So for example, a Flipkart or a Amazon, they have a product which is a marketplace, but there is a lot of analytics which goes in making the platform efficient. So how do you enable discovery of new products? How do you make the right recommendations to your right customers? Right. Similarly, for a bank, which customers are risky, which customers are less risky, what's the right interest rate to lend for various customers? That's the question, which again involves a lot of analytics. For insurance, for example, while I was at Aviva, the biggest question was which customers are likely to give us a second premium or a third premium so that our products become more profitable. So there are these companies where there are captive units where people work, and then these companies have access to a lot of customer data, and they can use that to make their products more meaningful. The second set of companies today are basically companies who are offering services for doing these analytics services. So some of these companies who actually fall in category one, which I mentioned, do not have the skills and the expertise to solve all the problems themselves, right? So they in turn rely on these category two companies, which specialize in analytics. So these are companies where they'll have, so for example, a Mu Sigma or a Fractal, where there are people with that specialized skill set who can solve a specific problem and then help the companies make their products better. So there are these analytics services companies. So these companies are focused on analytics. Now they've been in place for so for example, Fractal started back in 2001. Mu Sigma started back in 2006. So they've been there for some time. And again, the spectrum there varies from companies with a few people, so 2 or 3 people on the lower side, to all the way up to, let's say, 3,000, 4,000 people. So that's the second group of companies. The third one is the established large IT companies or MNCs which traditionally offered IT services, but now with analytics coming in or demand coming in from their clients, they are kind of reskilling their workforces, or they are looking into analytics as their focus area. And then you would find again the likes of TCS, Wipro, Infosys, to management consulting. So I was talking to someone at McKinsey a few days back, and they were telling how McKinsey has started looking at themselves as a analytics company rather than as a management consulting company. So there are these companies who are there who had a different forte previously, but they now look at analytics as a focus area. And then finally, the fourth category I would say is startups or people who are building data products or data services. So for example, there are companies who are building APIs for solving very, very specific problems. So there was a company. So I was again talking to a company which is providing really interesting healthcare solutions, or solutions to logistic problems based on some proprietary algorithms which they've created. So this healthcare company, they've created a small patch which can go on your body, and it starts capturing a lot of data about your heart rate, about various other parameters, and then they use that to provide you recommendations about your health. So those are broadly the four kind of categories in which I would classify the industry. Again, the career opportunities in them. So I personally like the startup space a lot, because you're changing a lot of things. There is a lot of exciting work happening, and I think it's a great time to be in a analytics startup at this stage. But at the same time, even if you are in a MNC trying to change your products, we have seen companies like Google, Facebook, Amazon come out and say that they are rethinking their entire lines of business around AI and machine learning. So there is again a huge demand in industry with scarce supply as of now.
Okay, so this brings us to the next segment, because I think we understand the industry. We also understand how the ecosystem analytics Vidhya platform is enabling into this ecosystem. And now I would like us to focus on the industry, and the industry I am in, the skill industry, right? Because we have the requirement, we have the industry trying to solve problems, right? We have the ecosystem. Now, a lot of people who are wanting to skill themselves, whether right when they are still undergraduates, they're still like pursuing their masters at that level, vis-a-vis to anybody, from 5, 10, 15, 20 years of experience, all ranges, because it's never a bad time to learn and skill yourself in a hot area, especially if you enjoy working with data, especially if that's something which you have somewhere enjoyed, but you just haven't looked at it as your pure play career. But here's an opportunity. And then there are these, companies who are looking to see how to really get people to do that, cover this bridge between their aspirations and getting them to solve the problems. I want to hear your more objective view, on this platform, and that how do you see this industry, and how do you see this industry differentiate in producing talent? That's something if you can touch.
Sure. So, as I look at the analytics training or reskilling industry, so to say, today, broadly, again, I'll go back to my own, segments thing. So I see two broad kind of, courses or opportunities in the way people can look at reskilling. So there are, these long-term courses being offered by, by really reputed institutes. So you see courses from ISBs to IIMs, which are year-long courses, which take up a significant investment, but at the same time are run over a long duration. You typically attend these classes one weekend every month, or depends on course to course, but typically you'll work over the weekends. So that's one format, and you have to be really sure about making that kind of investment into reskilling, and I think the kind of investment it requires, you need to be able to arrange for that to go in that direction. So that's one option. The other option which is there, where you see relatively short duration courses, so anywhere between, let's say, 3 months on the lower side to 6 months on the higher side, where there is a lot of focus on solving specific needs or specific areas. So, for example, a course offering data science using, let's say, R or Excel or Python, where you have taken a call that there is a particular language you would use. There are a set of areas which you will focus on, and then there you see again, multiple players coming out. Some of them, so for example, in case of digital Vidya, you bring a lot of expertise from your experience on digital marketing training. So you can so you would look at making the course very hands-on, focus on industry needs. So there are various people who are focusing on this area, and again the idea is to run short-term courses with very, very focused and identified needs, so that that results in upskilling of people. So broadly, for the end user, the way I recommend to them is, if you're very early in your decision making, that whether you want to, let's say, test out analytics as an area, or you're not sure, it's probably one of the areas you want to explore, you might look at some of the openly available courses, or let's say YouTube channels, and then see whether it is what you actually want. If you've crossed that stage, I think the short duration courses can be a good fit. So where you can start identifying your needs or career paths. So you can say that, let me start with a particular language, R or Python or SAS, and then build my expertise around that. Once so if you have done that, or you're absolutely sure that analytics is something which you need, you can also look at some of the longer term investments, but I typically avoid telling people that making long term investments without getting sure that they would want to make a career in analytics. So that's broadly the way I look at industry. I think again, overall, if you just take a step back and the way you see industry, there is still a lot of unmet demand. Especially so if you have a high quality offering. That's something which is always up for grabs. So a lot of clients whom we work with on the jobs portal side, typically their hiring cycles are anywhere between 6 months to 12 months. So if a position becomes vacant today, it takes them anywhere between 6 to 12 months to fill the position. So if they try through the traditional recruitment channels. So if you're really good at what you do, and then you're continuously learning and relearning and reskilling yourself, then there is a huge unmet demand which you can look out for.
Right. So let me just follow up with this question, which if I don't ask you, it's going to nevertheless come up, right? I'm like battered with this question on an everyday basis. That in the space when the skill set, right, from the core skill of SAS, R, and Python in terms of languages, what should they pick up? Especially if they're focusing on the programming aspect of it. Right? Obviously, there's this huge chunk, as you had mentioned, people who have the data and they need to solve problems. I tell them that there's nothing as powerful as knowing how to leverage your Excel, advanced Excel, statistics on it, right? But once somebody decides to go into deeper and go into machine learning at some point, then you need to pick up one of these. Right. So everybody asks which one, right? So you get. Let's hear it from you. I've kind of been saying it in a lot of different ways, I believe. You tell us.
No, I can listen. So I'd written. So this was one of the articles I'd written very early in analytics with the days about which tool to choose. And at that time, actually, Python was not usually mentioned in this comparison. So it used to be SAS versus R, and those were some early days. So I was trying Python, and I said Python looks like the language which should be there in this consideration. And I think 3 years after I had penned down that article, I've just refreshed it a few days back. But in terms of my view, so first thing, which we should think about is not everyone needs to be a data scientist, right? So there is a huge chunk of people out there who can apply analytics in their day-to-day roles, in their day-to-day questions which they ask. So if you are a sales manager, and you can analyze data by yourself, like, which are the potential leads to follow up, and then they give you faster conversion. Or if you are take any example, and you will find areas where you can do basic analysis by yourself to solve problems. And then typically these people need to just understand basic analytic skills, and then they can do most of their work on Excel or Power BI or SQL or any GUI driven tools. So there the question of language typically doesn't come. The language question typically comes when you want to go on and then become a data scientist or a business analyst in the domain. And there again, the way I say to people is, you should so no company would hire you because you know multiple languages, right? So companies hire you because they want to solve problems using one of these tools. So again, there is no point in trying to learn everything. The first thing which you should think about is take one tool and become good at it. Once you've done that, you should then try learning more techniques rather than more tools. So that's the background. Now within this, if your target jobs or the areas where you would want to be present are, let's say, MNCs, so banking industry, or let's say clinical research industry. So these are some of the industries where SaaS has been there traditionally as the market leader, and it would probably stay for near future as the tool where they use. So none of the bank would go out and then put SaaS out of production from their, let's say, risk scoring mechanism. So you would have SaaS there in these areas, and in those areas SaaS is really efficient, right? Then there within R and Python, so both of them have really a strong community, strong ecosystem, a lot of functionalities to offer. So typically modeling technique would come out first in R and Python, and then probably after a few years on SaaS. So going forward, R and Python are clearly the future tools to use, because they provide a lot of ecosystem. They provide a lot of flexibility, and more importantly, you don't need to invest significantly in procuring those tools. So if you're starting afresh, I would say, and unless you're dead sure that you want a role in banking, or you want to you are in a bank and you want to upskill yourself into an analytics team, I would say R or Python is the way to go. SaaS, if you're clear about your sectors and then the companies if you want to go to. Now within R and Python, again, if you're from statistical background, R obviously becomes the natural way to go, because there is a lot of research which has been done traditionally in R. If you're from coding background, Python becomes the easier way, because it's faster to learn if you come from object-oriented programming background, and can be picked up easily. My personal bias is slightly high towards Python because I think I see that it's a production ready. It provides a production ready environment. It provides integration between a web development platform to a machine learning platform, especially if you're building products on the web. And lately, there a lot of deep learning frameworks and work has happen on Python rather than on R. So my personal preference is Python, but both of them provide very rich ecosystem in terms of functionality. So that's the brief answer.
Right. I'm hoping that this question will not repeat itself during our Q&A session. Uh, I think we're really running very close to our hour, and we have questions coming in, from our folks we had asked early on, and maybe there will be some more questions here. So if you can just finally, if you can talk about the conference, and then we'll move to the questions, because I've seen some very interesting topics on the conference you're hosting in November. So if you can tell us a little bit about it.
Yeah, sure. So yeah, we are really excited to do this conference in November. So it's for those of you who don't know, it's happening from 9th of November to 11th of November in Bangalore at MLR Convention Center. And the idea behind doing this conference was, so I've been in multiple conferences myself, and a lot of times these conferences end up being very business focused. So as a practitioner, I really find very little value, so typically what happens is, if by end of the conference you have found 3 sessions where you have learned something new, that's a great takeaway. That's how I've seen at least conferences. So most of the conference would talk about analytics at 50,000 feet. You'll see similar use cases being shared, and that's what we said, that we should create a conference which is very practitioner focused, which is focused on people who do data science and who want to learn about various tools, various techniques, and various hands-on things in data science. So you'll see that the entire conference is shaped in that manner. So anyone who is taking a session is a practicing data scientist himself, or they are leading a team of data scientists and they've been doing data science for a long time. So you'll find the top data scientists from India, from across the globe. So Dr. Kirby Bonu is one of the biggest influencers in analytics and data science. He's coming to the conference. All the top data scientists from Analytics Vidhya platform, all the top Kaglers are coming to the conference as either speakers or they'll be there. And as part of this conference, so we are doing 5 workshops. We are doing 10 hack sessions. So a hack session is basically a live demonstration of a problem solving. So someone would take a problem on stage and show how that problem gets solved in real life by a data scientist. So really hands-on conference for people who want to learn. I think there can't be a better way to come and learn multiple industry applications, see what the people are doing, developing a network of people who are doing data scientists. So tomorrow when you come across a question that, I want to solve a particular problem, or what do people do if they face a problem like this, you can leverage that network. You can see some of those practices getting shared. So that's the thinking behind Data Hack Summit, and it's panning out really well. So I can see the vision with which we started getting fulfilled. I can almost visualize how things are shaping up, and we have got some really great partners and sponsors as part of the summit. So I'm really looking forward to it.
Sure, I really wish to see this kind of conference happening right out here in India. So wish you all the best, and look forward to continued access to this
Sure.
insight, this information, this real data science work, and how to approach. So yeah, I'm sure this message as it goes out, a lot of folks will be able to consume it in different
Sure.
formats, right? Yeah.
Yeah. Yeah.
So what we'll do is we'll shift to, I had, asked some of our folks to put down their questions if they had something for you. So I'm going to read maybe three of them. So let's start. Prasad asks, what statistics are usually used in data science?
You said Prashant? What was the name?
Prasad.
Prasad. Okay. Okay. So, Prasad, statistics is one of the key areas which you should learn and understand, especially so in your early days in analytics. So, in terms of bare requirement, I would say you should be very comfortable with descriptive statistics. Obviously, the mean, median, mode, the definitions, how do you compute that? And you should be comfortable with the basic inferential stats. So how do you prove or disprove a particular hypothesis? What are the various kind of tests you need to do to prove or disprove those hypotheses? What are some of the errors? What does a type 1 error mean? What does a type 2 error mean? Why are there scenarios where one type of error is more costly than the other kind of area? What are some of the trade-offs? So those are the requirements you need to have, and more so from practical application side of things. So you may not know the exact derivation or the exact theory behind it. You can always find the formulas from internet nowadays. So, but you should understand what to be applied when and in what scenarios. And if you know this much, that's good enough to start. That's good enough to, in fact, understand most of the things. If you need anything more specific, you can always come back and look at the texts and the lectures. So at a advanced level, you'll probably need the survival modeling, or you might also need hidden Markov models, but not at the start. So as long as you are comfortable with descriptive stats and basic inferential stats, you're good to start.
Thank you. So we'll move to the next question. This is from Nanddeep. He asks, he's listed quite a few questions. I'm picking up one of his. What is the difference between working at a merchandising company, which has a data analytics unit, vis-a-vis working at a company which totally deals with data analytics?
Sure. So let me explain this. So let's say you are working for Tesco, let's say, right? So Tesco would have its own data about how the customers travel, or Tesco is basically an equivalent of Big Bazaar in UK. So it's the biggest supermarket chain out there. So basically, you get data about what the customers are buying, where are they picking things from, what are the things people buy together, how frequently do they buy things. So if I bought a 5 kg, let's say, atta today, when is the next time I buy? So that gives you some indication about my consumption patterns. So if you're in a company which is using all that information, and then it could be any field, not just merchandising, it could be any field, and so those teams basically use that data to solve specific problems. So in this case, you will say, what should the store placement be like? So which product should I put near to each other so that they sell more? So if you're owning that data and you're trying to answer that yourself, that's category one, as I mentioned. But a lot of times, because traditionally these companies, or Big Bazaar was set up by people who didn't have analytics capabilities, or they didn't have the right expertise. So there are companies who come with that expertise, and solve these problems. So these companies would come in as a consultancy company or a consultant and give you very specific recommendations which can be applied on field, and that's the role too. So in second set of companies, you start with a client problem, you build a solution around it, you hand over the solution to the client, and then typically move on to the next project.
Right. And the way I would say it, in the first one, data is yours, you own the data and you act on it. In the second, you help somebody else's data get insights, outcome prediction. So good. So I'll move to one of the questions from Tatya. Sorry, I don't get your pronunciation right. He asks, with options like hackathon, won't businesses look at competitions for solutions instead of taking on full-time employees? That's a pretty interesting question.
So that's actually true. So companies are using hackathons for both the solution, both the cases, finding the right talent or finding the solutions. And I don't see it's a either or. It's actually a and. So there are companies who need people to solve problems, but they cannot give the data out and open. So you need the talent to be in your company and to solve the problem. And there are areas where you can open source the problem and get the best solutions out. The second thing to keep in mind is, it's not a one-time exercise we are doing. So even if you build a predictive model today or get a solution today, you need to continuously improve it. You need to find ways to improve it regularly. So for example, Google updates its search algorithm every few days. So there is a dedicated team of people who is working on that algorithm. So you would need talent irrespective. You can get crowdsourced solutions to accelerate that journey. So I don't see that as a either or question, to be honest.
I completely agree. Thank you, Kunal. So what we'll do is we'll take one last question now, because it's over the hour. So it's very, in some way, I think you have answered this before, but maybe it's a good way to summarize and close. Ari Warisan asks, I have completed the data analytics course in Digital Vidhya. How can I practice or train myself on everyday basis to master in this analytics field? What is expected to enter into the industry?
Sure. So if you're looking to, if you're looking to enter the industry in a hands-on role, you should try and get at least 2 to 3 projects on your CV before you apply. Just one second. Yeah,
sure.
So you should try and get at least 2 to 3 projects on your CV before you apply for various roles. And these projects can come from hackathons, these can come from competitions, these can come from open data sets. These can also come from your business problems. So the company which you're working on, if there is a problem which can be solved using data, you can use that. What you should also do is, once you've worked on a problem, create a GitHub profile, put your codes on GitHub, show what you have done to people on social media, take feedback from people in industry. So you can write about your approach on LinkedIn. So what I was saying was, once you've worked on something, just showcase it to world, take feedback on it. So put it on your GitHub profile, share it with people on social media, take feedback in terms of how that particular problem can be solved in a better manner. Talk to people in industry, and once you've done that for 2-3 problems, that's the right time to apply for various roles in industry. So in the industry, if you're applying for hands-on role, typically they'll ask for your experience, and that experience should come from some of these competitions and data sets. So that's what I would recommend to start with. And in the early years, I would say that keep trying, keep learning new stuff. The domain is changing very quickly, very dynamically. So a few years back, deep learning was not there as a domain. Today, there is a lot of work happening there. So get your basics right. Get don't jump to advanced topics straight away. Build your base of statistics, common machine learning algorithms. But once you've built that, keep learning and then keep improving yourself.
Okay, cool. So I think you have, with this answer, you've also kind of covered what are the next things people should be learning after getting their foundation ready. So that is deep learning. So Tatya, I think your last question, what are some of the next generation tools in data science? I think that's Kunal did wrap it up with the same answer. So what we'll do is we will thank Kunal from everybody here. Thank you so much, Kunal. I can see you're not keeping at the best of your throat, at least.
Not a problem. Not a problem. Thanks. So
So
thanks for having me over, and great to talk to people and help them with their any career related questions they might have. So thanks a lot for this interview.
okay, then we goodbye for now, and we look forward to reading and getting to know the ecosystem more and from Analytics Vidhya and seeing students actively going there and participating. I think that's a very important message coming out for all of you out there. Bye-bye.
Thanks everyone. Good night.